Okay, so this is part 2 of my last one that I did with Ishan. This is getting a little bit more into the weeds of it. I know this is like literally a minute or two before the stream's supposed to end, so I'll speed through this. Thanks, Emmanuel, for the hour long. Oh, also, thank you, Arch, for actually working with Zoom. This is the first time I've been able to like go off my laptop. Yeah, and if you didn't know, that's me. I don't care. Ethereum networks. Okay, so a big thing that you need to understand that the Ethereum network, when you talk about Ethereum, there's more than just the Ethereum that you know. Like the one that's like, I think it's $2,900 now. That's the Ethereum mainnet, and specifically the coin on it. You can spin up several different networks using that same Ethereum source code. So it's no longer OPSEC, but for ISTS, I spun up the ISTS mainnet with the chain ID 22 ISTS 22. Of course, the ISTS is in lead speak, but so real cool. Actually, in the beginning, there was only one Ethereum network. Now there's Ethereum mainnet and Ethereum Classic. This was caused by a whole bunch of issues where someone stole a bunch of Ethereum, and they're like, okay, we don't want that transaction to happen. So they forked the entire network and said, okay, that transaction's no more. We get our Ethereum back. And then there's Ethereum Classic, where that transaction did happen, and the Ethereum mainnet where it didn't. So that's all cool. There's also testnets. Testnets are specifically for, well, testing. It's kind of in the name. There's a bunch. That's only a few of them. Technically, there's a ton. And then like other networks, of course, the infamous ISTS mainnet, the most used ever. Currently down for I have no idea why. Binance Smart Chain, that's in another Ethereum network. Binance itself runs that, and it's for lower costs. Very similar to the Matic mainnet, which is Polygon. Similar, low cost, high availability, and just better for trading than the actual network where you have to pay like $10 every time you make a transaction. Of course, that goes much higher in certain times, but I think I checked and it was like $10 for a transaction right now. There it's like cents. So the purpose of these extra networks. First is the test nets. These are, as you guessed, testing. There is no actual authority for which like you can say, hey, I want to buy some Ethereum. They go through what are called faucets. So you go online and you can just get Ethereum. It's not worth anything. Like for the ISTS mainnet, I had like, I think it was 9 times 10 to the 56th Ethereum. Like it was a stupid amount. And I gave every team like 100 because I'm rich like that. Then there's those secondary networks. These are called scaling networks. That's the Binance and Polygon. So those are not to replace the the Ethereum mainnet, but to act in to correlate with it, to improve everything. So there's like a bunch of ideas of like roll-ups and a bunch of other things to improve Ethereum itself without actually affecting the Ethereum mainnet. And so that goes into it. I won't go too deep. And then alternate networks. So there's a ton of networks just for making shitcoins. I think one of the most infamous, like it's actually doing pretty decent, is like Avalanche. So it's like literally, you can go online and be like, oh cool, I got a new coin. And you can just make them like that. And their service is very good, but infamous for getting shitcoins because it's so easy to make. But yeah, several reasons. We'll go into it later, there's even like security reasons to have testnets or just extra networks. Almost hit the wrong one. So that idea of Ethereum faucets that I was talking about. So realistically, I do not have as much Ethereum as my wallet says it does. Or well, I do, but on other networks. So this is basically a way of just getting Ethereum so that you can use the testnets because everything is based on being able to transact. So you can literally go on websites and be like, cool, I'll send you 1 Ethereum a day. Just put your wallet ID in your Twitter and then send me the link. That's like legitimately one. There's another one where it's like, okay, 5 Ethereum and you log into Google for me. There's like a bunch of weird ones and most of them are safe. I wouldn't trust all of them. Okay, now we're moving into this idea of smart contracts. I promised I'd go fast. This is 3 parts, and part 1 is by far the longest. So the idea of smart contracts. What is a smart contract? We kind of went over this yesterday. It is basically a program on the blockchain. Think of it like, I've tried to make a lot of correlations. Think of it as just you're deploying an API. Every time you have a contract, it's just saying, hey, these are the functions people can access. You can work on it in the background. You can keep this information backend. You can let them access X, Y, and Z. And you're going to keep track of, I don't know, W. And it allows you to keep very strict records, and all transactions are immutable. So it's a really good way of doing that. So there's this idea of contracts being able to be accessed and modified. So there's an idea of pure transactions, which is like, hey, can I get my balance? And that has to be like 0 cost, because like, are you going to pay to see your balance? It's kind of impossible there. So there are certain transactions, or I guess it's considered an access, for which you're able to actually interact with the contract. And then transactions themselves aren't editing the base contract in which they're based on. It's basically saying, hey, I'm going to call this request that requires some modification of the contract. Or not a modification of the contract, a modification in terms of which the contract defines. So we get into Solidity. Solidity is one of the largest programming languages for these contracts, and it's very simplistic. It's object-oriented, high-level, and you literally just like create like contract, and you're like, okay, it implements this, and like, okay, this is a mapping. It's really simple. It's highly influenced from like C++ in terms of notation. Statically typed, really cool. Other alternatives for it, there's Viper and then Yule and Yule Plus. Those are 2 other ones that you can use. Won't go too much into it. I'll talk about Solidity a little bit more in a second. Well, right now. So every single contract is going to start off with Pragma. This is basically saying, for our compiler, use this set of, well, this compiler or higher. And it's taking your low-level or high-level code and saying, okay, this is going to be run on the blockchain, or we're going to compile this for the blockchain. Then every time you create a contract, you write contract and what you're going to call your contract. And then you encapsulate everything, curly braces. Every time you have a function, it's function, and whatever you're going to call your function. It's pretty simple. I think anyone who's ever seen a programming language can probably figure this out, and even people that haven't. And then the only like weird stuff, there's an idea of an address. Addresses are vital to anything on the Ethereum network. So they have a type of its own. And it makes it just really simple to say, okay, cool. And finally, another weird one, mapping. This is basically just a dictionary. They call it a mapping, though. Maps one X to Y, one type to another, or one type to itself, or to the same type. Basically like that, and it's highly used. Think of it even as like just a SQL database. Some people even use it for that. It's pretty cool. Then just general types, Boolean, integers, addresses, contract types, bytes or byte arrays, mappings. Byte arrays are strings. They don't call them that for whatever reason, but they're very expensive to use. And then function types, there's that pure, which we were talking about. It's completely free to access, but that relies on any of the lines in your function not actually making any modification to the contract itself. And then there's the idea of public-private, like who can mess with this contract, like, or who can see this function. And then internal, external is very similar. I'm not exactly sure what exactly the use cases are, but they're still it. And then finally, everyone's favorite, all statements end in a semicolon. Then we get into pretty much VS Code, but it's online, Remix, and this is completely for compiling contracts or similar things. They have a bunch of stuff. You can use like I think even like they support like Solarium contracts at this point. But yeah, it's an online editor, compiler, and deploy mechanism for smart contracts, and it can connect to pretty much any network as long as you supply it with the correct stuff. It also runs its own EVM, which is Ethereum Virtual Machine. So say you don't want to like mess with the testnet at all. Cool. We're just going to virtualize one in your browser, and you get like couple thousand Ethereum. It's really cool. So I think this is one of the last slides before I go into just a short demo. There's this idea of types of smart contracts. We see those like ERC20, like there's even like BEP20 tokens. These are basically just requests for comments, ERC being Ethereum request for comments. And most of the time, it's just an interface and says, hey, if you're going to have this type of contract, you have to implement X, Y, Z, and D function. And cool. Okay, now you have an ERC20, and you now have an actual token. So ERC20 is for fungible tokens, meaning that all tokens are the same. ERC 721 and 1155, NFTs, non-fungible, and they are not the same. And we can kind of devolve into like digital identity standards. There's one for just European research. It's actually pretty cool. Ethereum-based cryptocurrency. That I'm still not exactly sure what that does, but it's used for like bug fixes with ERC20 contracts. And then there's also security-specific ones, ERC 1400, ERC 1404. And basically, these are just saying, again, how are we going to implement these? What functions do we need in order to implement something like this? Okay, cool. 3. How do we use any of this? This is kind of just like Max is talking at me. He's saying words I don't understand. Cool. I'm a crypto investor now. Ritzek coin. I'm going to make you all a lot of money. Yeah, no. So we go back to this idea of ERC20 contracts. Like I said, it's literally an interface. I pointed over there like there was a screen. This is technically for like ERC. I have no idea why it was different, but this was like the nicest photo I could find. But it's exactly the same. It says, hey, you need to make something called total supply, balance of, transfer, allowance, approve, transfer from, transfer, and approval. And right there, you got a token. As long as you fill in those functions, we don't care how, it has to be within those bounds. Go back to your, like, I don't know what, like CSCI 101, where, like, you have to, like, implement an interface right there. You literally maybe need a first, like, you can Google the stuff. Like, it's not that bad. It's scary how easy it is at times. So, we're going into our demo. Cool. Max already did our demo pretty much for us. I didn't want to take up your time, so I sat through and did it. Cool. And I don't want to touch people's laptop. Okay, so we're at Remix. We have our contract. We actually have an entire module that we import. It says, hey, let's make a token. Okay, our contract is an ERC20. That's how you do an inheritance. And then we call in constructor. Our token is going to be called RITSEC, and each coin is going to be called an RS. How many do we want? I don't know. Let's put 1 million. Cool. And just like that, we can actually deploy it on our Ethereum virtual machine. We say, cool, deploy, runs, cool, going, show up. Yeah, you get all your functions. You can access them. Hey, what's the name of this? Cool. That's the idea of the pure function. Whereas these, whatchamacallit, orange ones are non-pure functions that will actually cost gas in order to execute. So cool. We deployed it. I actually previously deployed one of these to the Ropstein network. So right here we have a block explorer saying, hey, this transaction went through. You uploaded it complete. Whatchamacallit, like, congrats, you made it. You're a crypto guy now. Next we go into, we see our transaction for the contract. We can actually view specifically what the contract is. We go into MetaMask. We're so cool. We import our token. If you've ever messed with trying to import tokens before, you got this idea of token contract. Well, we already know what that is. We just copied it from where it was. And, oh, it didn't miss like the 0x. No, maybe not. Did I copy it wrong? But that's possible. Watch, now it breaks. I don't know, RS. It auto-filled for me before. Wow, nice. Okay, maybe I screwed this. Oh, that's why. See that? We're not on the right network. So now it should be all cool. It says, cool, you have the RS, that's your token decimals. Cool, you got $1 million, you import it, you got money. Basically that easy. You're the Fed.
You basically
Yeah.
just give yourself money.
Yeah. And then you're like, cool, now I want to transact it. Okay, I'm going to send it to this account. Actually, no, I don't want to send it to that account. That's my personal account. Yeah, cool. I'm going to send you 100 Ritzek coin. Cool. Yeah, I'll pay the Ethereum. Why not? And it's sending. It's really that easy. It's kind of scary how fast you can get into this stuff. Yeah, sent. And we go into our account 1. And, of course, we have to import our token because no one knows what the hell a Ritzek coin is. And we got 100. Okay.
Give yourself 9 times 10 to the 56 coin.
I don't have that amount right now. So
Give yourself that much.
yeah, I won't. Everyone, it's nice out. I don't want to keep you for any longer. I know that I've already kept you over your time. Any questions?
When will we see this implemented in CTFD so that we could get RIP-SEC coins to any challenge dealers?
I don't know. Who's gonna do the monetary backing for it? Because I want that
CTFD.
that crypto cash. Okay, if that's it. Thank you guys.